Good afternoon, integrated topic students. This is Miss Codner again, coming into you via, I don't know, internet, I guess. Okay, so right now I need for pencils. There's a collection of white paper that they're getting, which if you're getting off the website, it is classwork number 1, number 2, and number 3, if I'm not mistaken, for February 3rd and 4th's class. If you have a calculator, you can use that if desired. And also, we're going to use your notes to reflect on what we're going to be working on today. So we're just taking a closer look on that linear combination or that process of elimination in order to find our point of intersection. Yeah, I say that like 5 times fast. Okay, so the 3 papers that we have, the first one starts with, let's look at some more system of linear equations and solve them by forming a linear combination of the equations. So for number 11, I know we're starting at 11. We have x plus 5y equals 4 and x minus 2y equals 11. So to solve this system of equations, you should form a linear combination of the equations by adding or subtracting them. So you're probably like, what? Basically, what it's asking, if you were to solve this system, the system meaning those 2 equations, are we going to add them or are we going to subtract them? So hopefully you're going to say you're going to subtract them. The reason why, which one is giving me the same number and the same signs? So hopefully you're saying my x's, okay? So the x's, they both have ones in front of them, and they're both positive. So that's why we're going to subtract them. So when we subtract them, it asks, what equation results when you combine the equation using this operation? So if I'm subtracting them, what do I get as a result? So my x's are going to be eliminated. So now I have 5 minus a negative 2y, which gives me 7y. And 7y is going to equal 4 minus 11, which gives me a negative 7. So then part C says, what is the value of the unknown in this equation? So the unknown is y. And what y is going to equal is a negative 1. Because after you divide 7 on both sides, you're left with y equals negative 1. And how would you find the value of the other unknown in the given system of equation for part D? So in order for us to find the other unknown, which in this case is x, we're going to substitute, or sub for short, sub a negative 1 for y in either, ooh, it's getting ugly, for either equation. So we're going to use one of these 2 original equations to substitute that negative 1 in for the y. So let's go ahead and do that. So let's say we pick, let's pick the first equation. So if I pick that first equation, I'm just going to raise it up a little bit. My first equation is x plus 5y, but instead of the y, I'm going to put my negative 1, and that's equal to 4. So 5 times a negative 1 is a negative 5 equals 4. And I'm bringing down my x. So if x minus 5 equals 4, by adding 5 to both sides, that means x equals 9. So for part E, it states, what is the solution to the system? Anytime you see the word solution or you hear the word solution, you should be giving me an ordered pair. So that ordered pair is 9, comma, negative 1. So remember, it's your x, comma, then your y value, okay? So I'm going to add that point or that solution is basically, if I graph it, that's the point of intersection. So for part 12, so the questions are basically the same. We're just basically solving or basically going through that process of elimination step by step. So it's just helping you guide your thinking. So for part A, it asks the same question. To solve the system of equations, should you form a linear combination of the equations by adding or subtracting them? Okay, taking a look, looking at your x's, looking at your y's, hopefully you're saying subtracting them. And why is that? Because my x's have the same number, which they have 4 in common, and they're both positive, so that means I'm subtracting. Let me change colors here. So when I subtract them, what do I get? My x's are going to cancel out. Then I have 4y equals a negative 8. So part C says, what is the value of the unknown in this equation? My unknown is y, so my value is a negative 2 because I divide both sides by a positive 4. And how would I find the value of the other unknown in a given system? So we're going to sub or plug my negative 2 for y in either equation. You can seriously tell this is almost the end of the day. Okay, so let's go ahead and do that. So let's pick one of those 2 equations we want to use. We use the top one before, let's use the bottom. So we have 4x plus, and what's going in there is a negative 2 equals 10. So since we have a plus a negative 2, that's basically 4x minus 2 equals 10. Okay, when you plus a negative, it's going to be negative. Okay, just think about when you do multiplication. A positive times a negative is going to be a negative. So my next step is going to be 4x equals 12 because I added 2 to both sides. If 4x equals 12, that means x equals 3. So the answer part E, what is my solution to this system? My solution is going to be 3, comma, negative 2. So that will be my point of intersection. So as I stated before, this paper, all it's doing is just breaking down these concepts of elimination step by step. It's just kind of training your thought process. So for 13 and 14, oh, and also 15, after we did problems 11 and 12, the class worked on these by themselves, but I'm going to go through this run through quickly. So this time, I should be adding my equations because if you look at my y's, I have the same number, which is 7, but there are opposite signs. So that's why I'm adding. So when I add them, I get 7x equals, what is that, 64? All right. So with my 7x, oh, geez, you can tell it's the end of the day. Definitely not 64. Let's try 63. Yeah, okay, end of the day. So part C, what is the value of the unknown? So if 7x equals 63, that means x equals what? Hopefully you said 9. So how will we find the other unknown? I'm going to plug 9 in for x in either equation. So let's go ahead and plug that 9 in. So if we're plugging in for x, let's do, I don't know, the first equation. So if I do the first equation, I have 3, instead of an x, there's a 9 going there, plus 7y equals 41. So 3 times 9, 27. So 27 plus 7y equals 41. Then I'm going to subtract my 27 on both sides. So then I'm going to have a 14. So that's why y is equal to 2. So my solution is going to be 9, comma, 2. Looking at 14, should I add, should I subtract? I should add. Because if you look at my y's, they have the same number, but different signs. So when I add these two, I get my 9x equals 18. Therefore, my unknown is x equals 2. How am I going to find? Let's see if it only gets me this. It gets me a lot of stuff. Don't you wish we had the clone button for everything in life? All right, maybe not. Or am I just being lazy? Yeah, pretty much I'm doing lazy. How many times did I do it? Okay. So, we're going to plug 2 in for x. Okay. So if we plug the 2 in for the x, picking an equation, let's go with the first one. So I have 4 times 2 minus 3y equals negative 1. 4 times 2 is 8. 8 minus 3y equals negative 1. Negative 3y equals, we're going to subtract 8. That gives me a negative 9. So that means y is equal to 3. So my point, or my solution, is 2, comma, 3. And lastly on this page, solving the system, so it gives you a little extra practice. So if you want to pause it to try to work it out on your own, do so. And then you can check your answer once we're done. If you're not pausing, here we go. So, am I adding or am I subtracting? If you notice your x's, they're exactly the same number, exactly the same sign, so I am subtracting. So when I subtract, it's 7 minus 3, which gives me a 4y, equals 7 minus a negative. If you minus a negative, it turns to a positive. So that'll give you 12. Therefore, y equals 3. Then we're going to take that and plug it back in for one of our equations. I'll use the second one. 2x plus 3 times y, which I'm going to replace that y with a 3, equals negative 5. So I have 2x plus 9 equals negative 5. So that means 2x is equal to what? A negative 14. Therefore, x equals negative 7. So my point of intersection is negative 7, comma 3. Okay. So it's just reiterating all the stuff that we did on the previous lesson. So the next page, instead of just doing number problems, we're actually looking at a word problem. I know. I don't want to do word problems. Suck it up. Because you're going to have to eventually test the waters with the word problems. So here's the situation. Again, anytime you do word problems, you want to pull information out. So, children attending a birthday party will receive a goodie bag that's worth either $2 or $3. The parents given the party know that 11 children will attend the party. They have exactly $28 to spend on the goodie bags. How many bags of each type can they buy? So first things first. This situation, they're giving us information. But what's jumping at us? I know that I can get either a $2 or a $3 goodie bag. I know that 11 children are going to attend the party, and the parents that are throwing the party have exactly $28 to spend. And what I'm looking for are how many bags of each type. So that is the reason why I have two unknowns. There's a $2 bag, there's a $3 bag. My goal is to figure out how many of each type I can get. So they're saying let X represent the $2 bags and Y represent the $3 bags. So it says, what does the equation X plus Y equals 11 tell you about the goodie bags? So if X is representing my $2 bags, Y is representing my $3 bags, the 11 is representing the children. So can we say the number of goodie bags needed? Okay, so we need 11 of those bags. We don't know how many exactly right now. So for B, what does the equation 2x plus 3y equals 28 tell you about the bag? Can we say the total amount to spend on bags? It's amazing I'm doing this with one hand. So it says create a linear combination of the equations in problem 1 by adding the equations. So if I slide this over a tad, just a tad, oops, not that, just to give myself a little room. I know it's kind of hard for these papers. So if I want to create a linear combination by adding the equations, so I have my two equations right here. I have my x plus y equals 11. I have my 2x plus 3y equals 28. So if I want to solve those equations by adding, reflecting back onto your notes, do I have my x's and y's lined up? Okay, so right now my x's are lined up, my y's are lined up. Do we have the same number? We don't have the same number. So that means I'm going to have to do some multiplication. So it's up to me, depending on what I want to multiply. What do I want to get rid of? Do I want to get rid of my x's or do I want to get rid of my y's? Let's say I want to get rid of my x's. So in order for me to get rid of my x's, I need to have the same number. So in order for me to get the same number of my x's, I need to change this 1x right here into a 2x. By doing that, I got to multiply by 2. But remember, I can't just multiply just that term. I got to multiply the entire equation by 2. So when I do that, I get 2x plus 2y equals 22. So with that, I want to, oh, didn't work. So with that, I'll put it down here. I want to combine those two. So in order for me to combine it by adding, that's what it's asking, I need to have the same numbers, but different signs, right? So instead of me adding, or sorry, multiplying by 2, I'm going to need to multiply by a negative 2. In order for us to add, we have to have the same number, different signs, right? So us multiplying by a negative 2, which gives me a negative 2x minus 2y equals a negative 22. That will take care of everything. So when I add it, I'll get 1y, which will go right here. So y equals 6. Because after I add, my x's are going to cancel out. Then I have 3y plus a negative 2y, which gives me y. And then I get 28 plus a negative 22, which gives me 6. Okay? So that will be me creating it. So now part B of that question asks me to do it by subtraction. So remember, in order for me to do it by subtraction, it has to be the same number, same sign, in order for me to subtract. So instead of multiplying by a negative 2, I'm actually going to multiply by a positive 2. So when I multiply that x plus y equals 11 by a positive 2, in this case, I'm going to get 2x plus 2y equals 22. And we're going to solve this one by subtracting. So when I do it by subtraction, I'll have 1y equals 6. So now part C asks, could you solve the system formed by the equations in problem number 1 using either of these linear combinations? Why not? I can, as long as my answer is positive, I can use either method. So we'll say yes, as long as result is positive. Because think about it. If I get a negative number, we're looking at the situation. The situation is dealing with bags. Is it possible for you to get a negative bag? No, it's not possible. Okay? So I know we kind of stepped along. We say multiply side by 2. We already did that. We did that right here. We got our results. Okay? We don't need to do part 4 because I don't want to get too funky with it. Okay? I don't want to get too funky with it. But we did solve it, and we got the same answer, didn't we? We got y equals 6. So now we have to go back and recognize what is y. Y represented, if I slide this over a little bit, y represented the number of $3 bags, right? So we got y equals 6. What does that mean? So you should say it means that the parents can buy or did buy 6 of the $3 bags. Let's go this way. Okay, so the parents bought 6 of those $3 bags. But what else is going on? So we found one of them. So they bought 6 of the $3 bags. How many did they buy of the $2 bags? So let's think. There's 11 children. Okay, let's go back. There's 11 children that's going to be attending. They're each going to get a goodie bag. It's either worth $2 or $3. If 6 of them were the $3 bag, how many were of the $2 bag? Hopefully you say 5. Because all you have to do, you could take your answer as 6 and plug it back in to your main equation, into one of the two equations. You could do that and figure out the 5. Or you can just simply think about it. If there's 11 children and 6 of them are going to get a $3 bag for some sick and twisted reason, that means 5 of them are going to get a $2 bag. All right? So there's times that you can just go ahead and substitute or just use your head. You can use that mental math. That's perfectly fine. So that was off of the classwork number 2. So now what you see before you is a classwork number 3. Yeah, it was all about classwork because we really needed to hit hard on some of these concepts. So this one, I actually like the students go ahead and got their answers themselves. And whatever they didn't finish, they finished for homework. Okay. And also, one of the things, it seemed like problems 1, 2, 3, and 4, everything is dealing with the elimination or the linear combination method. Okay. So if you have the same number, the same sign, you're subtracting. If you have the same number but different signs, you're going to add. Okay? A lot of people did pretty well with 1 through 4. Once they saw a word problem, they started freaking out. But when you adjust or when you work the word problems, try this method. First things first, tell me what you're looking for. So for number 5, we got Chang ordered 5 burritos, 3 tacos, and paid $5.90. A week later, he ordered 2 burritos and 3 tacos and paid $3.80. So part A states, how much does 1 burrito cost and how much does 1 taco cost? So right there is what we're looking for. We're looking for the cost of a burrito and a cost of a taco. So first thing, what's going to represent our unknown? What variable is going to represent the burrito and what variable is going to represent the taco? So you can say X and Y, you can say B and T, whichever. As long as you understand what's going to represent the burrito, what's going to represent the taco, so when you set up your equations, you'll be ready to go. So let's just say burrito is going to be my X, taco is going to be my Y. So now, there's 2 different situations. One order, he had 5 burritos and 3 tacos, and he paid $5.90. So that's really one equation. So if he had 5 of the burritos, so that's 5x, and so he didn't take away 3 tacos, he got 3 tacos. So we're going to add my 3 tacos, which is 3y, and paid. That was his total. So his total equals was $5.90. So that dealt with 1 week. The other week, he had 2 burritos. So that's 2x and 3 tacos. That's 3y. And he paid $3.80. So from here, we just pulled this information out from the word problem to create our equation. So from here, it should look like just like the notes from this class and also from the notes from last class. How are we going to solve it? First things first, are my x's and my y's lined up vertically? So looking at my x's, yeah, my x's are vertically, my y's are vertically. So which one has the same number? Which one? It is my Y's. What are their signs? They're both positive. So, same number, same sign, we're doing what? Subtraction. And then from this point on, you should be able to solve it. Okay? So, pulling information out from the equations. Okay? So, they finished up the class by doing this third worksheet. Whatever they didn't finish, if they wanted to take it home to finish it and bring it back, that's fine. I was going to go over a couple problems from it because I kept hearing the same questions over and over again. So I'll address those for next class. In addition, their homework assignment was originally stated as a classwork assignment. The reason why, since we had a delay, I wasn't able to give it as a classwork assignment. So I decided to give it as a homework assignment, even though it is entitled classwork. Okay. Um, they only have to pick 3, notice the smiling face, out of the 6 problems. Okay. They get to choose which 3 problems they feel comfortable with in solving in order to get a score of 3 out of 3. Okay. So each of them are worth 1 point. If they're able to solve for one variable, not solve for the other variable, I gave them half a point because you gave me one variable. So if the whole thing's worth 1 point each, you only give me one of the variables, you're going to get half credit, okay? Because I'm still missing my other variable. So they get to pick 3 of the problems that they want of the 6 for homework, okay? So in order to answer these, again, I'm going to say it almost at every recording, I'm available Tuesday, Wednesday, Thursday in room C107, which is my classroom with Ms. Cabanallen. On Friday, Ms. Cabanallen is in my classroom, first lunch during Wildcat Hour, and I'm in the Media Center, first lunch during Wildcat Hour. Okay? So if there's any questions or any concerns, if you're only here partial, or if you're only here before Wildcat Hour because you have Cat North, see if you can make arrangements to see me during your CATS class. Okay? It's possible. You can check in with that CATS teacher or you can check in with me and I can email the teacher. You're not leaving your CATS just to play around. You're coming in here to do work for the 15 minutes and moving on. Okay? So again, give it a try, turn it in, and don't be late with your assignments. Talk to you later.